In one of our previous videos, I did an explanation of how high frequency inverters can outperform low frequency inverters if they are properly installed. So this is the part 2 of that video where we'll be showing the guidelines, then the configurations that I talked about in that previous video. I'm going to be showing you on how to configure it so that you can have the maximum performance from your high frequency inverters. So come with me. Hi everyone, my name is Bashir from Internet. So the first thing you want to do, you want to place your board, your inverter on the board, then place your. Now, the first mistake is, first of all, the distance it is going to have should be 20 centimeters at least from here to any form of obstruction. 20 centimeters. So, but the board is up to that. But wherever we'll be mounting it, we need to leave the space up to 20 centimeters for both sides, here and here, 20 centimeters. So it has to be 30 centimeters from here to any obstruction here, and 30 here too, from top to any obstruction at the top. So we'll mount it now. So this is the DC breaker and the DC surge, which are very important. This one is the AVP, which is to protect the input voltage coming to the inverter, while this one is for output. This one is specifically used to limit current, because this AVP has both current and voltage cutoff. So this one is for input voltage monitoring, while this one is for output current monitoring. It's very, very important. So you can make it more, you can add your AC surge and AC input breaker, but to me I'm okay like this, as in for this particular size of the inverter. After setting up your inverter, you want to go ahead and configure it. So let's start with the configuration. You press and hold. So the first one is reset. If I want to reset, so let me enter. I like to reset my inverter back to factory. So it has reset everything. Now let's move. The second one is output source priority. So I'm going to enter. So I'll choose solar first. I want solar to be powering my load, my output load. If there is no solar, then it will go and pick NEPA. And if there is no NEPA, then it will go and pick battery. So I'm going to put it at SUB. So SUB is solar first, while USB is NEPA first. When there is NEPA, it will ignore your solar and it will be using NEPA. I don't like using that, because then you will have sun, but then your prepaid will be running your units. So, and you have the sun there for free. So I rather use SUB. And if you pick SBU will pick solar first, then battery. It is when battery is low that it will now go and pick NEPA, if there is NEPA. So solar first, then battery, then NEPA, if battery is low to a certain level. So the next one is code 2, which is the total charging current. So here I have just 5 kilowatt of lithium battery. I'm okay with 60 amps for total charging current. 60 amps is okay. So I'm just going to move. If I'm not okay, I can just go in and increase it. So it can go up to 110, but I'm okay with my, in fact, I'm okay with 50. I don't want the battery to have high charging. So let's move. APL code 3, which is input voltage range. So yeah, APL from 90 volts to 280 volts. I like using UPS. Oh, sorry. So UPS is from 170 volts to 280 volts. I don't want the inverter to work outside that range. If the voltage is less than 170, I don't want it to charge. So then you select your battery selection, which is battery type. This is AGM, like gel batteries. So FLD is flooded. I like to use user define. User define gives me the room to set my battery parameters by myself. So I like to leave it at user define. So let's move. And user define gives you advantage to configure code 13 and code 12. We'll get to it later. So this one not really important. Your frequency 50 Hz. We are in Nigeria. So your utility charging current, which is your charging current from NEPA. My battery is 5 kilowatts. I'm okay with 30 amps. I can increase it if I want, but I don't. And if I put it at 100 amps, trust me, it's going to charge the battery at 100 amps. So I'm leaving it at 30. So this is code 12, which I told you about. If you pick SBU in your output source priority, it will not change to NEPA until your battery gets to 23 volts. You know, I told you it will pick solar first, then go to battery, then from battery, when the battery is low to a certain level, it will now pick NEPA. So this code 12 is the one responsible for setting that. So I can say I do not want it to switch to NEPA until it gets to 22 volts. So until the battery is low to 22 volts, it will not change over to NEPA. So I can leave it like that, but no. Let me just leave it at 23. I didn't really select that option. So then code 13, when it goes to NEPA, you know, when your priority goes to NEPA, as in the battery is low and it has gotten to 23 volts. When it goes to NEPA, it will charge. Once the battery charges to the level that you set code 13 to, it will release that NEPA again and go back to battery. That's what this code 13 do. The code 12 will determine when to go and change over to NEPA. Code 13 will determine what level your battery is supposed to go to switch back to battery. So code 16 SNU, yeah, charger source priority. So you want to pick which source do you want to be using to charge your battery. Solar first, definitely, but you can pick solar and utility, which is SNU, or you pick solar first, which is CSO, that's solar first, or you pick only solar, which is this OSO, that's only solar. But let's leave it as SNU. So the next important parameters you need to configure is 26, 27, 28. Yes, 26. And code 26 is your bulk charging. My battery says 29.6, so I'm going to set it to 29.6. I want the battery to charge to 29.6. Then 27 is float charging. I like to leave this one just 28.5. Depending on your battery parameters, and 29 is your low battery cutoff, 20 volts. You can increase it and you can decrease it, but I like to leave it as 20 volts. So, and the rest you can go through it, but those are the important settings you need to go through to set for you to get the maximum efficiency from your inverter. So I'm going to leave it for it to save. If I press escape, it will not save. This is escape, it will not save. So I'm going to leave it for it to save. It has saved. So let me go back and confirm. SUB 50 amps UPS. So the settings. Now here, what we have here is our protection devices. So this is a DC breaker. There is a DC surge here, but the one we brought has issue, so we have to come and replace it later. So these are the important parameters and the important gadgets that you need to protect your high frequency. If they are the most, you can choose to add AC breaker and all, but you see these four, they are very, very important with your setup. So this is the DC breaker, this is the input protection, while this is the output protection. This input, what it does, it's basically just to cut off high voltage and low voltage. What the output does is to cut off overload. So here we'll be configuring voltage, while here we are going to be configuring current. So let's turn this on. So I'm going to set it P1 270 volts for high voltage. That's too high for me. I don't want my inverter to be exposed to 270 volts. So I'm going to bring it down to 250 volts. Yes, for high voltage. So for the timer, this is the timer, the time it will take to peak again. I want to increase it. Yes. So that if there is high voltage, before it will peak, it will check the current. I can reduce it, let's say to 40 amps. So those are basically what I need to configure on this one for input. Then for output, all I need to configure is the current, the output current. So 63 amps. This inverter is 4.2 kilowatt inverter, so I'm going to set it to 3.5 kilowatts. So if we convert 3.5 kilowatts to current, we are going to have 15.9. So let me put it at 15. So when they reach capacity of 3.5 kilowatts for any reason, or maybe they plug something, rather than for this inverter to go and trip as overload, this guy will do the work before it even gets to the inverter. Let's test the load. So I'm going to off NEPA. So our inverter now. Let's see what this guy can power. This is the pumping machine. Pumping machine has started running. We want to see what it can take the time. So we'll turn on the pumping machine, turn on the fan. We'll turn on the freezer. This is 165 liter freezer. The freezer is working now. So this is the fridge in the kitchen. They are all running at the same time. Turn on the lights. So we are currently at 1.3 or 1.4 kilowatts, and we are at 6 amps here. So the inverter is working just fine. We can still add double of this, but we won't do that because we have just 5 kilowatts battery. So that is it. This can handle as much as you want.